Welcome back. We're up to training our vision transformer model. And you might have already done this because that was the challenge at the end of the last video. So if you have, well, what'd you find? How'd the model go? If not, let's now do it together. We've got an optimizer. And what I might do is I might bring this down into here so we have everything in the one cell. That way our instance of optimizer isn't created up here, and then when we run our model code, it's done differently. And I'm going to set the seeds here so we can get as reproducible results as possible. And we have results equals engine.train. Engine takes a model, of course, so we'll pass in the ViT model. And then we have a train data loader, which is of course going to be our train data loader instance that we created right back up in section 2, create data sets and data loaders. Seems so long ago now. And then we have test data loader equals test data loader. And then what else do we have? Epochs. Let's train for 10 epochs. We'll pass in our optimizer, which is the ever faithful atom optimizer. And then we'll pass in our loss function. Recall that we wrote this engine.train function way back in pytorch going modular. If we just jump up into here, pytorch going modular, and we have, here we go, engine.py. That's where we wrote this script, so we don't have to rewrite all of our training code. And device we want to use is the device. Let's just make sure that we've set that to GPU. CUDA, that's correct. So you ready? We're going to train our first custom implementation of a vision transformer that we've replicated from scratch directly from the paper on our food vision mini data. So let's bring it to life in 3, 2, 1, no errors. All right, what do we got? Here we go. We got a progress bar. Beautiful. Oh, we're already over 50% accuracy. That's pretty good. Oh no, back down to under 20. Goodness me. Well, let's see how this goes. So we've got about 5.5 seconds per epoch. So the model we're using is quite big, but the data set we're using is quite small. Oh, we're stuck here at below 20%. Oh, we've jumped up over 26% on the test data set. What ways? Oh, the loss is going up. What's going on here? Does it look like our model is overfitting or underfitting? Well, it definitely looks like it's underfitting because, well, we want this training accuracy to go higher, don't we? It looks like it's going up on the training accuracy, but the test metrics are kind of all over the place. Well, that's kind of sad because all that time spent replicating such a big and beautiful vision transformer model, and it doesn't really do too well on our own data set. Now, why might that be? Why do you think? What's different between our training setup and the original paper's training setup? If we look into here, here's what I want you to think about before the next video. We're going to go through this, but if we search data sets, there's a little section here, experiments. This is probably the part to read through. So set up data sets, have a look at the data that they use to achieve their results. And then also have a look at the different model variants. We've kind of already done that. We're using ViT base. And then have a look at training and fine tuning. And then see the results. So if you go into results, why do you think the original vision transformer paper got the results they did? And why aren't we getting those kind of results just yet? So have a think about that. But you should be happy. You should be stoked. We just trained our first vision transformer that we built ourselves on our food vision mini data. Although the results aren't that good, at least the training is working, so we can start to think about how we can improve this model now. So have a think about that, and we'll cover it in the next video. I'll see you there.